Well, hello again. It has been a week. I wanted to be back sooner, but I decided to take a week off and continue genealogy research. That's my third hobby. I had two, just the Thunderbird and the genealogy. Now I've got the Thunderbird, the genealogy, and the radios again. But I'm better at genealogy than I am this stuff. I've been at family history research for about 40 years, a little over 40 years now. So I better be, better than this. But it's a straw. I'm so far back now on all the lines. It's very, very difficult to get accurate information. So I did get some stuff though done for you. I went ahead and I made a complete list of all the capacitors I'm going to need for this radio and the Atwater Kent 856 that we'll be doing next time. I used the parts list on the Airline here. Just went right down there, I looked at the it says condensers right there, which means capacitors. And the ones that I wanted, these 0.0001, what is that, 125, I guess, those are all mica caps. The ones I ordered would be the electrolytics, 0.1s, 0.006, 0.1, 0.1, and then these are all mica caps. Here's another, but a lot of 0.1s in this radio. And then I ordered, I didn't realize it was that low on capacitors. I ordered 0.1s, 0.01s, 0.5s, or 0.05s rather, 0.005s, whole bunch of stuff. And I ordered them from Tony's Capacitors. His link is on the front page of the Antique Radio Forum, or down in the vendor link on the front page. You hit that, it pops up. And he takes PayPal and a whole bunch of other stuff. I really like the fact he took PayPal. Boom, I ordered it, and boom, it wasn't just a couple hours later. He wrote me back and said, "Yeah, thanks for your order. This is how much you owe." I paid it. I'm waiting now. It'll be a couple more days, I guess. The other thing I did was I painted the. I got the variable capacitor all painted, looking real good. I primed it with automotive self-etching gray primer, which I like. It digs right into the metal and gives you a good surface for your paint. Then I painted it with high gloss silver, which I did not like. I never do like high gloss anything. And then I sprayed it with satin clear. So we've got a real good protection on this thing, top and bottom. And let me make sure I can get a little focus here. This light might be a little bit too close. Anyway, it looks real good. Now all I got to do now is we'll go ahead and I'll have to oil these bearings here and get it to where it's a little stiff right now. It works, but it's a little stiff. I don't like that. We'll go ahead and oil it up. We'll put a little oil down in here, around there. I'll show you that when the time comes. We'll get that baby working good. Capacitors. I told you that we would talk about these capacitors in the last video. Some people refer to these, I'll go back over, some people refer to these as electrolytic cans. Some of them refer to them as filter cans. What they really are is electrolytic capacitors. Yeah, referring to them as a can is okay. Everybody that fixes radios knows what they're talking about. This, out of the Atwater Kent, is an electrolytic capacitor. It's a can, yeah, but it's a capacitor. It consists of a plate. The outside of the can. The outside of the can. That's one plate. The other plate is inside the can. Okay? And it's isolated from the outside of the can. And it's isolated from a rubber grommet. This one here, I whacked this baby off. I was planning to do something different with it. And I may still do that, I don't know. But there's the rubber grommet that separates the one from the Atwater Kent. It separates that plate from the can. Okay? Let's look underneath this one. Here you can see the bottom of the two electrolytic capacitors. There's one right there, and there's the other one, and they have an insulating washer, pretty thick one right there. Another one over here. Okay? And this nut will have to come off. I'm going to remove these cans. This nut, if I can get these wires and crap out of my way, this nut will have to come off on each one, and once that comes off, I'll be able to hold this larger nut right here. It's just a thin sheet metal nut is all it is, And I should be able to grab the can by hand and unscrew it to the left while I'm holding this big old nut here, and it should come right on out. I've got the first nut off, and after I did that, I could take this thing off also. There's some wires soldered to it right here. So we'll just move that off of there. We can leave this other nut on to get this one out. It's the same way over here. Now this thing is kind of interesting. We have an insulator here, which insulates it from the chassis. Insulates this plate from the chassis. And then we have the insulator here that insulates the rod up through the center from, which is a plate, from this plate. Okay, it's insulated. There's the rod, right? The end of the rod has got a thread on it. And it goes up in here. Now these things were filled with water, and either baking soda or boric acid. I was informed that baking soda, I didn't know about baking soda. I knew that boric acid was in a lot of them. And you can see right here in this Atwater Kent, see that white crap right there? Over the years, that water, sometimes, I had one time where they were filled with water right about to there. I thought I did a video of it. I can't remember now, but I poured them both out into a jar, or into a glass. That there was still some liquid in there, but normally they're dry as a bone on the inside, and the boric acid or the baking soda dries up, and you can see it sticking out of that can right there. Just dries up. It's just, look at there, it just flakes right off. Yeah. After a while, you know, the water just evaporates, and there's a hole in the top of this one that allows for expansion, I guess, of the water. This one has no hole. I don't know. Maybe it's around the edge there somewhere where it was coming through. I don't know. You know something? I don't care. We don't need them anymore. This is, what, 2024? And we don't need this crap. But, you know, you want to leave them in there for aesthetic purposes, originality. That doesn't mean you have to hook them up. You can just put them back in, shine them up, make them look good, stick them back in. And when people look at it, you know, they'll say, oh, wow, look at that. Everything's shiny, looks good, looks great, radio's playing. They don't know that underneath you've installed new electrolytic capacitors. Or, you can cut the can open along this edge right here. These are some of the things I've done. I think I did it with these, if I'm not mistaken. I can't remember. It's been years ago. You can either cut along here, nice and neat like. One guy used a tiny little hobby saw. And he would go around, you know, and cut, and then he would lift the top off, and then glue it back on when he was done. I used to cut them down about right here, all the way around, and then you can put new capacitors inside. You know, clean it out, gut it out, and make it nice and shiny and clean on the inside. And you don't have to mess with this, and you can leave you just cut that rod off right on the inside of the can, you know, right about there. Use a motor tool, you know, chop it off. You can leave this rubber thing in. You don't need to take it out. And then you can put silver metal tape around the, and once you get the capacitors in there, the new ones, right, you know, like this, and you stick the leads, you have to drill some holes down here, stick the leads through. Make sure the leads are heavily insulated. Make sure the hole is big enough that, you know, the leads are not going to touch this outside, because it's still probably going to be hooked to ground. So even though these things are independent of this, you get this positive lead here, touches this grounded can, you got a problem, you know. You just put some good insulation there, like heat shrink or whatever, and you'll be fine. Just got to be careful. That's called, when you do that, when you cut open a can, you put these kinds of capacitors, new modern capacitors inside, and you run your leads out and hook them up where they're supposed to go. That's called restuffing. When you get on the Antique Radio forum or any other forum, and they're talking about restuffing the electrolytic cans, that's what they're talking about. Cutting them open, putting those in, taping them up, gluing them up, however you want to do it, okay? Now this is interesting. Back to the hole where I took that capacitor out of, you'll see that there is an insulator right away. There's an insulator underneath the chassis right here. It just slipped out of place, just like that. So this plate right here is insulated from the chassis both above and below. That's what provides the below insulation. And that's what makes that capacitor different from this one. Well, now, what did I mean by that? Well, let's go ahead and get this insulator out. We don't need it anymore. And then we'll take a look at what we've got. Now, these radios are really interesting. People designed these things. And at first they looked like, what is this? Why is this like this? Now, we already understand why this insulator's here. The insulator's got to be... This thing's giving me a little struggle here. I don't like that. It better bend to my wheel real quick. Okay, there it is. This, we know why we have an insulator top and bottom. Because we have to keep this can insulated, or this plate insulated from the chassis. Well, what's this other thing? What the heck is this thing right here? What is that all about? It's connected to the negative side of this capacitor and a couple of resistors here, but there was an insulator between it and the chassis. The insulator was here, this one right here. So this is the negative side of the electrolytic cap. It should be connected to ground, right? Wrong! This one is. This negative side says right there, negative right on it. That's the negative end of the capacitor. It's connected right directly to the chassis. So yes, this one gets grounded, but this one does not. So what is this? Well, they had to have a way where all of these things could come together. The electrolytic and these resistors and things, and they needed a way to bring them together. So this is just nothing but a soldering tab, and they decided to fasten it insulated from, the bottom of the capacitor. And it provided a very nice, point for putting the wires together. Now we could take that off there and put a terminal strip there and do the same thing, as long as it's isolated from the chassis. Because you can't have these things touching the chassis because the way the schematic is. And we're going to go over that in a few minutes. The second one is out, and as you can see, there are no insulators here because that can is directly connected to the chassis. The outside plate is, and there is no soldering tab either, okay, like this right here. Now, one more thing about these electrolytics, or the filter cans, whichever you prefer, they don't all have just a rod in the center that goes all the way up, but it doesn't really go all the way up. It goes up to about this point right here, which would be about right there, I guess. Some of them have a plastic screen around that rod. Just as if this pencil was up through there like that. It would have a plastic screen around it. I'm not sure why it's porous. It's got holes in it. I've seen those in some of the radios I've opened up the cans on, and I don't know what that purpose of that is. I guess to keep the liquids from sloshing around too much. I don't know. I have no idea. And then also when I opened up a can one time, it seems to me it was on a Philco. Around the rod was a piece of metal that was bent like this piece of paper here, and it was around the rod, and it was almost the size of the can itself in diameter, and it went around the rod, and it looked like that when it was all the way around, completely all the way around, about like that. Okay, so there are different things you're going to find inside these cans. Don't worry about it. They're empty. You don't want them. You don't need them. Disconnect them, figure out how to put them underneath, or restuff them. That'll come with time and with other people helping you out, and just practice, really. Let's take a look at the schematic now and try to figure out which of these caps is which. We know that one of them is isolated from ground, the other one's grounded. That's the key. That helps a lot, okay? A look at the parts list shows that the C13 is an electrolytic capacitor. It's 8 microfarads at 300 volts. And if you go down a little bit, you see there's the second one. This radio only has 2. Some of them have more than that. This one is C18, also at 8 microfarads, but it's rated at 50 volts higher, 350. C13 is C18. Now the job becomes trying to find it on this mess here, because everything is really blurry. Can't hardly make out half the numbers. Look at that. What is that? I don't know what that is. Just like C blob. Alright, so we know that these are filter capacitors, and they're going to be somewhere near the power transformer, which they are already located there on the chassis. So C13, C18. Let me see here. Let's get a little clarity here. Now, up here, C13, at first I wasn't sure what that was. It looked like a C18. But it's actually, let me get a little zero in here there. Actually, I finally determined that it's C13. And we have to determine whether or not C13 is in fact this electrolytic capacitor right here that's grounded. I'm positive that's C13, but you know, I could be wrong in how it is. So, according to the schematic, if this is C13, the positive side, which would be right here, and this is the negative side to ground, it should be connected. We follow the line around, it should be connected to what I think is C18 right here. Now this is the positive side of that. This is C18 positive side right there, and the negative there. So let's see if the two positives from this capacitor to that capacitor. Now see, this capacitor is very close to the rectifier and the transformer. You know, and you would expect it to be there, an electrolytic. It wouldn't be up here in the antenna, the part of the schematic, that's for sure. Not an 8 microfarad anyway. So anyway, let's go ahead and look here and see what we got. We have the positive side of this one and the positive side of that one definitely soldered together. Look at there. You move one, you move them both, okay? Definitely soldered. Alright, that's we're on a roll here, folks. Now let's go to the other side of this one where the negative is. This is pretty sure now this is C18. Now, I've already written, I think, C13 on this one. I'm going to write C18 on this one because I'm positive it's that. C18. I love writing on crap in these radios. It's fun. Especially the schematics. You know, it's not like it's the only schematic in the entire country. I can get another one. Anyway, now this, coming out of the negative side, we know that it's not supposed to be grounded. So what have we got coming out of there? Well, we've got a resistor right here. And it goes up to a resistor right here. And then that resistor comes over and goes to a resistor right here. Now this resistor is gray, black, and yellow. Now gray, black, and yellow, let me see. Let's see if I got a blue. Let me get this thing out of my way. Shucks, come on now. Okay, C15. Now if we come through the capacitor, we know that the two positives are together already. And then if you go through the capacitor, you see that it comes across and goes into the field coil. This is the field coil located on the speaker. Then you come up here to a voltage dividing network, I guess is what they call it, R15. Let's see what R15 is. 800K. That's exactly what that is, 800,000 ohms. That's a lot of ohms. And then it comes from there up to this one here, which is brown, gray, and yellow. That would be the next one right here. R14, 180K. That's exactly what that is. That's 180K. 1, 8, and then you got 4 zeros. Okay. The last resistor is this one here. Is it's brown green. It's got an orange dot down here in the bottom. You can't see it unless I roll the entire chassis around. So that's going to be 15000 15K. Now that is R13 right there. We'll go over here to R13. 15K. 15,000 ohms. Okay, so I think that pretty much cements it. This resistor is connected to the negative side, and all the other resistors go through it. We've got a wire that comes out of the negative side right here. That goes over. Well, it's just part of the. Speaker plug that they're using, the connection over here. But we should have one going into the transformer. Yes. This one right here goes into the transformer. Well, where's that on the schematic? Just, you know, just for the heck of it, you know. We come over here, it's hooked to the negative side. There it is right there. It goes up By the way, this is the center tap of the B plus coming off the negative, and that is the most negative point in the radio. At least that's what I've been told a million times. I've never proved it to myself. Okay, I hope I didn't confuse everybody. Yeah, we did. We now know that this is C13, this is C18, and they're both 8 microfarads. These two are rated at 450 volts, and they're probably good. But you know, there's this old thing about reforming capacitors. I've never been a believer in that. Yeah, you get it to reform, you're just looking for trouble down the road because one of them's going to crap out. Maybe a year from now, boom, it's going to go, and you got to go right back into the chat. Put the new ones in. They don't cost that much. Change them all out. Get rid of this junk. We don't need junk like this. We got good modern stuff. Dump it. Don't leave capacitors in like this. It's your radio. You do what you want. One more thing on leaving comments. I don't know why people are still doing it, but they're leaving me anonymous comments. I'm not going to comment on anonymous comments. I'm going to delete them. Unless I know who they are, people that have been with me for years. If you're some new guy out of the blue, you blow in there, you don't want to tell me who you are, see you later. One more thing, I'll close it out. Speaking of people fixing radios, you should not only be watching what I'm doing. You should have like 4 or 5 radio restoration guys, or maybe even 10 or 12 that you pop into once in a while and watch what they're doing. They may have, or they probably do have, better ways of doing things than I do. Don't limit yourself to one restoration guy. That's the worst thing you can do when it comes to doing anything like this. When I was in college, I was taking Spanish. I had to take a language. So I took Spanish, and our Spanish teacher cautioned us. She said, look, don't, she's after a while in this Spanish class, you're going to go a couple of semesters, you are going to understand me and the way I speak Spanish, but that's bad. She said, you need to get out there and diversify. She said, because, if you go to a Spanish place or a place where they speak Spanish, you're not really going to understand what they're saying because I'm the only one you can understand. All right, so get out there and look at some other guys. You don't have to comment on them if you don't want to. Just go out there and look at them. Check this guy, check that guy. There's some very smart people out there. Until next time, this is John.